Now, this is a binomial. Okay, it's a binomial because bi just means two, and nomial means in this context that means terms. Okay, so this topic is also sometimes called binomial expansions. Now, what they do is they take binomials like this, and we raise them to different powers, and we expand them, and we see what happens. Okay. Now, if you're like me, you're kind of like, what does this have to do with anything? This is like the worst segue in all history. Okay, so stay with me. This is a pretty simple one, right? To the power of 1, nothing happens. Okay. But when you raise the powers, things start to get a bit interesting. Okay, for starters here, I know you know what this expansion is, but I'm going to write it like this for a second. I'm going to do it in full longhand, okay, because I'm going to try and make the connection between algebra and arrangements, okay? Now, if I actually take each term and I think about order, right? So I'm going to go A times A, then A times B, then B times A, then B times B. Okay, now, I have 4 combinations here, okay? 4 different ways of doing this. That 4 comes from its 2 to the power of 2. See why that's important in a second, okay? All right, now when you put that together, you get this result. Which is quite familiar, okay? But, go for this 2. It's really important, okay? We'll come back into a second. Let's do the next one up. Okay, again, I'm going to expand it out long ways, okay? So I'm going to get A plus B times this guy, right? Which is actually this. Okay? You're wondering why I'm making you do all this extra writing? Just stay with it, okay? Let's write it all out. This time I'm going to get A, B, A, B, A. Okay? And again, but with the B out the front. Okay, now, how many terms are there here? There are 8 terms, namely 2 cubed. Can you see why it's 2 cubed? Think about it as an arrangement question. Can you see why this is 2 cubed? Because I'm now trying to think of 3 different things. I'm trying to fill 3 boxes. Every term that I get out here has 3 terms, right? 3 bits. And then each time I've got 2 options for how to fill them, right? That's 2 cubes, right? That's why there are 8 here, okay? All right, let's combine it all together. So I get A cubed. Now, the way we write this in algebra by collecting like terms, we don't really care about order. Notice that, okay? So we're actually turning it into an NPR to an NCR, okay? Watch that. This is the same as this, which is the same as this, okay? So I've got 3a squared b. This is the same as this is the same as this, okay? So I also have 3ab squared. And then that loner hanging on the end, okay? All right, now look at these numbers with me. These are the important ones, okay? I'm going to do one more because I'm going to start running out of room if I do any more than that. And then I wonder if you can see it. A plus B to the 4, okay? I'm going to actually just write out what the expansion is, okay? Because I already know what it is ahead of time. It's going to be 4b plus 6 b squared plus 4 ab cubed plus, oops, no a's left. Okay, now, I know you probably recognize these numbers from Pascal's triangle, hopefully in year 7 if we taught you anything, but what does it have to do with all the arrangements you're talking about in this 2-letter business, okay? Well, think about these numbers, okay? 4, 6, 4, okay? This question here, asking this question, how many of these do I have? Or, you know, how many of these do I have? Is really like saying, okay, how many permutations are there? Sorry, this one lines up with these underlined ones, okay? Where I've got to come up with a 3-letter word, right? And 2 of the letters are repeated, okay? And then the other one is the leftover, okay? So how many ways is that? We just established that was about NCR, right? So I'm trying to come up with a 3-letter word And I've got how many repeats? Well, I've got this this double A, okay? So that's 2 factorial, 1 factorial. The 1 corresponds to the B, okay? That's 3 choose 2, okay? You see that? This comes from the repeat, okay? In the same way, I actually should write this as 3 choose 1. That's the proper way. This one over here, because of the symmetry of it, is 3 choose 2. That's why it's the same number, okay? We established that these are actually the same. Come up here, okay? What's this one? This is how many ways can I make a 4-letter word, and I've got an A, B. That's what I got to play with, okay? So it's a 4-letter word, and I'm dividing by that 3 factorial, 1 factorial. Okay, that's 4 choose 1 or 4 choose 3. They're the same. Okay, what about this one in the middle? Yeah.
4 factorial.
Yeah, sorry. That's what I meant to say. 4. I've got 4 different spots to fill. Yeah. Now this one I've got A's and B's, right? All of the ones that look like this, A B A B, B A B A, and so on. Okay, they all lump together. I've got to come up with a 4-letter word, right? And there's a double up of A's, and there's a double up of B's, right? That's 4 choose 2. 4 choose 3. Now, that's kind of interesting, isn't it? Does it work all the way to the ends? There's a 1 here and a 1 here, right? Does it work? Let's think about it. The pattern goes 1, 2, 3. If I've got to make a 4-letter word, right? And they're all repeated. B, 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 B. How many ways are there of combining them? Answer, 1, right? And, weirdo, if I've got, sorry, wrong color. This one over here, okay, what's this correspond to? 4 factorial on, Now, it's actually the same, isn't it? It's the same as this guy over here, right? But I'm actually thinking of it as, rather than 4 factorial, 0 factorial, I'm thinking about the other way around. This is 4 choose 0, okay? So another way of saying that, the way you used to say that is, I've got 4 and I don't want to pick any of them, because you all suck. So there's only one way to pick none of you, which is to pick none of you, okay? So, what you've got is these guys appearing, right? Which, by the way, if you can't remember, that's the way, a faster way of writing NCR, right? Okay, so can we generalize it? Can we generalize it? If I have some kind of binomial expansion, right? Raise it to any power you like, so long as it's an integer, okay? What I'm interested in is these numbers here. Of course you can build them off using Pascal's triangle, but the problem with that is, for instance, if I want this to be a plus b to the 20, okay, that means I've got to build the first 19 rows, which will take forever, okay? I can go directly there if I use these things, okay? So where do these numbers come from? Okay, my first coefficient, well, it's always got 4 at the top. That came from here, right? Whatever power I'm raising to. Okay? So it's n choose, now, the first one, n choose 0, okay? And the first expansion, which is just a to the whatever power you're raising to, okay? Now when you move along, you're going to go the same number, choose up 1, right? And because you've gone along another term, this power is going to reduce, but this one's going to increase. And it keeps going. This will be n minus 2, and this will be 2. Now, because I raise it to the power n, if I raise it to the power of 4, I'll get 5 terms. If I raise it to the power of 3, I get 4 terms. Here, I should expect to have n plus 1 terms, right? So this will add all the way up until now. What's the last couple of terms, right? Well, 4 choose 3. So that's n choose just 1 less than n, right? And where I'm up to is just 1a left over, and I've almost got all the b's. And the very last one is n choose n, right? Which again is just 1. So you got this symmetry happening here, okay? So I wonder how well I did if you can see why algebra is actually about arrangements, right? It's about trying to work out, well, how many of these can I fit together? That's where that 4 comes from, or the 6, or the 5, or the 10, or the 20, or whatever. Okay? So, to let you try